Today we're going to learn about a tool that can be used to help us solve exponential equations. We're going to learn about the method called method of common bases. All that means is when I'm looking at a problem, let's say example 1, in order to solve, I need to figure out a way to write 16 and 32 so they have the same base. Now if you recall, the base is part of our exponential expression. We have our base, which is a number, and then we'll also have an exponent. It's okay if the exponents are different. What we're looking for is a way to write 16 and 32 with the same bases. So we first need to think about what family are 16 and 32 in. So we're going to go look at our power table. Well, I see 16 and 32 both show up in the 2 family. 16 and 32 both show up in the 2 family. And it looks like I can rewrite 16 as 2 to the 4th and 32 as 2 to the 5th. So let's do that. Everything else stays the same, but I'm going to rewrite 16 as 2 to the 4th. I'm going to rewrite 32 as 2 to the 5th. Bring down the exponents that were already there. Nothing changed about our equation. 16 is now just represented as 2 to the 4th, and 32 is now just represented as 2 to the 5th. Now we solve these equations by bringing down our exponents. Now that the bases are the same, we can ignore them and just focus on the exponents. So we're going to have 4 times 3x minus 3 equals 5 times 2x minus 4. So now I'm going to multiply. Again, I'm going to multiply. And here we're just using our opposite operations to solve for x. And I divide, and I see that x equals negative 4. We were able to solve it. That's it. This method even works for the complicated looking problems. Let's take a look at example 2. Again, all I'm trying to do is figure out how to write 9 and 243 with the same base. So let's go see what family they're a part of. All right, well, I see 9 and 243 are both a part of the 3 family. So I can rewrite 9 as 3 squared and 243 as 3 to the 5th. Awesome. So I'm going to rewrite 9 as 3 squared. I'm going to rewrite 243 as 3 to the 5th. Cool. Now I'm just going to bring down my exponents. Once again, we didn't really change anything about our problem. Now all we have is just 9 represented as 3 squared and 243 represented as 3 to the 5th. And now that the bases are the same, we can ignore them and instead focus on our exponents. So I'm going to bring them down and just focus on them for the remainder of the problem. All right, I'm going to multiply and get 6x plus 6 equals 5x plus 10, and use my basic opposite operations to solve. x equals 4. And that's it. The key point with this method of common bases is simply to find how can you rewrite your bases so they end up having the same base.